The following demonstration will demonstrate the achievement of Disaster Management Working Group in AIP-3. This demonstration will illustrate how services in GEOSS can meet the requirement of producing a near real-time dispatching map based on the comprehension judgment fused by various sensor services in order to help the dispatching decision maker to make a rational decision for dispatching an emergency vehicle from a pier of specific origin and destination.
The major gap identified during AIP-2 was the link between observations collected during the warning phase and the observations collected during the response phase. Frankly, even in response phase, the gap still exists. In AIP-3, the scenario focuses on how to shorten the gap in response phase. To solve the above problem, a near real-time vehicle dispatching map producing mechanism will be conducted into this scenario. In this slide, we have two axes for timeline and the version of dispatching map, respectively. At timeline 0, the dispatching map producer produces the shortest path based on an in-situ sensor's information instead of producing the map without any near real-time information. At time t, the dispatching map is changed because of another event which may affect the previous status of shortest path.
First, the initiator logs into GCI portal and searches services which are related to disaster management, typhoon paths web service, and rainfall map for examples. Integrated client A subscribes or invokes these services when initiator finds out the suitable services. Actuator can query, monitor the real-time or near real-time information which are supported by these services. When the typhoon warning is issued, the SOS for typhoon warning sends a notification to those service consumer by SAS. When integrated client B gets this notification, it will send a request to SOS for acquiring sensor data. Integrated client B receives and displays the typhoon warning. Actuator can see the latest typhoon warning by operating integrated client B. Meanwhile, a monitoring service is activated by integrated client B, which will activate the sensors located at the potential disaster area and begin to monitor. When the observations over a specific threshold, say the accumulated precipitation, meets the yellow warning, SOS sends a notification to integrated client B by SAS. When integrated client B gets this notification, it will send a request to SOS for acquiring the sensor data. Integrated client B receives and displays sensor data from potential disaster area. The accumulated precipitation, for example, actuator can see the latest information by operating integrated client B. When the actuator needs to produce the shortest path map for vehicle dispatching, integrated client C invokes the services which are necessary for producing the shortest path map. For example, traffic report web service, flooding area web service. Integrated client C will deliver the request to those services and get the responses. A WPS for shortest path calculation will begin to perform the algorithm and find out the optimal solution under the constraints of near real-time traffic report and flooding area. The final shortest path will be delivered to integrate client C. The version 0 of dispatching map will be produced by the above steps.
At first, actuator zooms to the area of interest, say Taichung City. The client invokes the necessary service for dispatching vehicle, like real-time precipitation service, traffic report service, and flooding area service on the right-hand side of the client. And you can see the real-time rainfall just met the yellow threshold in this city. An actuator then click this huge compute button. The client will invoke a WPS for calculating the shortest path under the constraint of flooding area and the traffic report service for a pair of origin and destination.
Version 0 of dispatching map can only tell the optimal route in a specific time. Strictly speaking, this status will be changed until the next event, which is big enough to change the previous status, which means the dispatching map will be changed in any time. So if an event which will change optimal route, then the next version of dispatching map will be produced.
The client receives this sensor information continuously, as you can see. When the accumulated precipitation increases to 450 mm, this is an event which will change the status of the current dispatching map. So the client will compute the latest dispatching map based on the latest sensor information. The version 0 plus T1 is produced. After 1 hour, the accumulated rainfall goes to 600 mm. That is another event which will change the status of the latest dispatching map. The client will compute the latest map based on the latest sensor information. The version 0 plus V2 is produced.